video is covering section 2.1 from our trigonometry textbook, looking at the trig functions of acute angles. This particular video covers some of the same material that we looked at in class on Tuesday. An acute angle is one that is between 0 and 90 degrees. So we would have an angle less than 90 degrees, greater than, not equal, just strictly greater than 0 degrees. That'll be an acute angle. This first slide is looking at the trig relationships, similar to what we talked about in class, that the sine of an angle, for example, is the opposite side over the hypotenuse. We can see that the opposite side is y related to a point up here, B, which has the coordinates x and y. We said that there was this sort of shortcut way of thinking about this, so TOA, the O being opposite, the H being hypotenuse, and the A being for adjacent. We can also see the reciprocal identities here, where the sine and the cosecant are reciprocals of one another, right? We've got opposite over hypotenuse versus hypotenuse over the opposite. And the cosine and the secant are reciprocals. The tangent and the cotangent are reciprocals of one another. This is a new definition that we haven't seen yet. These are called the cofunction identities, and the functions that are cofunctions of one another have the CO in front of them. So sine and cosine are cofunctions. And you can see in this first set of relationships here that we have the sine of an angle is the same as the cosine of 90 degrees minus that angle, and vice versa. Tangent and cotangent are also cofunctions. So the tangent of an angle is the same as the cotangent of 90 minus the angle, and then vice versa. And then lastly, we have that secant and cosecant are cofunctions. And you can see again that we're looking at a particular angle versus a 90 minus the angle. If I have an angle A versus, actually I'll do it this way, plus another angle that is 90 degrees minus A, these two angles are going to be complementary. Complementary angles add up to 90 degrees. And if I added these two together, the A's would cancel, right? Positive A and negative A would cancel, and I would just end up with 90 degrees. So really what we're saying is that the cofunctions are going to be related to complementary angles. Here's a couple of examples. The cosine of 52 degrees is going to be equal to the sine of 38 degrees. That's because 52 and 38 is going to add up to 90. Similarly, the tangent of 71 degrees is going to be the same as the cotangent of 19 degrees. 71 and 19 will add up to 90 degrees. And then the secant of 24 degrees will equal the cosecant of 66 degrees. One of the places that we saw this in one of our discussions in class was when we were looking at the 30, 60, 90 triangle. Let's say that this is 60 degrees and this is 30 degrees. And if this side was a length of 2, this side was a length of 1, and this side was a length of square root 3. If we look at the cosine of 30 degrees, remember cosine is the adjacent side over the hypotenuse. That would be square root of 3 over 2. In comparison, if we look at the sine of 60 degrees, sine is opposite over hypotenuse. That would also be square root of 3 over 2. 60 and 30 are complementary angles, and by looking at this triangle, we get those trig values are going to be the same. Here's an example that we can use of solving a simple equation using cofunctions. For example A, we're looking at the cosine of some angle and the sine of some angle, and those two things are equaling each other. Since sine and cosine are cofunctions, that means that this angle here and this angle here have to be complementary, or another way of writing that is that theta plus 4 degrees plus 3 theta plus 2 degrees, those two things added together has to total up to 90 degrees. Combining like terms, I get 4 theta plus 6 degrees equals 90 degrees. I'll subtract 6 degrees from both sides. 4 times theta is going to be 84 degrees. And then I'll divide both sides by 4. And I get that theta is equal to 21 degrees. Here's a second example. Because the two trig functions, tangent and cotangent, are cofunctions, and we have this equation in an equality, this angle plus this angle is going to add up to 90 degrees. They're complementary. So 2 theta minus 18 degrees plus theta plus 18 degrees is going to add together to give us 90. I'll combine the like terms. I have 3 theta. The negative 18 and the positive 18 are going to cancel each other. So I have 3 theta equals 90. Divide both sides by 3, and we get that theta is equal to 30 degrees. Let's go back and check these answers. If I put 21 back in here for theta, I'll get 25 degrees here. And if I put 21 in the second side of the equation, 21 times 3 is 63 plus 2, that's 65 degrees. Yeah, 65 and 25, that adds up to 90, right? For this second set of equations, if I put 30 in the first equation, 2 times 30 would be 60. 60 minus 18 is 42. This is going to be 42 degrees. And this one is going to be 30 plus 18. This one's going to be 48 degrees. Yeah, adding 42 and 48 together, that gives me 90 degrees. We talked about these examples, about how we get the different trig relationships for the 30, 60, 90. This comes from an equilateral triangle that's cut in half. Just to make the calculations a little bit easier, we have each of the sides of the equilateral triangle have a length of 2, so that when we split it in half, this side becomes a length of 1. And then we use the Pythagorean theorem to find that missing side, x. So here's the work showing what we did. We did this in class, and so then we get this relationship where this other side here is the square root of 3. And then we can use that to find all of the trig values. So here are the trig values: sine, cosine, tangent for 60 degrees, and then cotangent, secant, cosecant, also for 60 degrees. We can go back and figure these out also, just looking at the triangle in a different way, for 30 degrees as well. The other special triangle we had was the 45, 45, 90, which comes from a square that we cut along the diagonal, right? And each of the sides of the square is 1, and then using the Pythagorean theorem, we find that that missing side is the square root of 2. And we can use that triangle to find the sine, cosine, tangent, and then cotangent, secant, cosecant of 45-degree angles. This last slide is one that you want to probably take a picture of or copy down, because this is going to be all the trig values that we're going to use on a regular basis. And you may want to memorize, in particular, these ones. The sine, mostly just the sine and the cosine. We can get the other ones for free. If you could memorize the sine and the cosine for 30, 45, and 60, and in class we'll talk about some easy ways to remember them. I'll show you some easy ways to remember them. But we're going to use this table in the next section. All right, thank you for watching, and I'll see you in class.